Black Friday, 2018. A retail platform emails 40 million users simultaneously. Within 60 seconds, 12 times normal traffic. Within 90 seconds, 3 servers dead. Within 4 minutes, checkout is down, $4 million lost in 11 minutes. They had servers, they had engineers. What they didn't have was a load balancer configured correctly. Think of a busy restaurant on Valentine's Day. One waiter serving every table. Doesn't matter how fast he runs, the system collapses. A load balancer is the manager at the door, looking at which waiters are free, seating you accordingly, except it's making that decision 1,000,000 times per second. A load balancer is a reverse proxy between your clients and your server pool. It accepts every connection and forwards it to one back-end server based on a decision algorithm. Think of an air traffic controller. The planes are requests, the runways are servers. The controller doesn't pick randomly, it checks which runways are occupied, under maintenance a dozen factors, and decides before the plane lands. There are 2 layers where load balancers operate, Layer 4 and Layer 7. Layer 4 operates at the transport layer. It sees TCP and UDP packets. It does not see HTTP headers or cookies. It's like a postal sorting machine. Routes by zip code, never opens the box. Doesn't know if you're sending a feather or a bowling ball. Fast, but blind. Layer 7 operates at the application layer. It reads the full HTTP request, makes routing decisions based on headers, URLs, cookies, then opens a new connection to the backend, like a customs officer who opens your package, reads what's inside, routes it to the right department. Slower, but infinitely smarter. AWS ALB is Layer 7. AWS NLB is Layer 4. Nginx and Haproxy can do both. Now, the algorithms. Most tutorials stop at round robin. Round robin is a toy in production. Round robin rotates requests across servers in order. Like a teacher handing assignments alphabetically, Aaron always goes first. It assumes every request costs the same. A PDF render and a username check are not the same cost. Round robin doesn't know this. Least connections sends each request to whichever server has the fewest active connections. Like choosing the shortest checkout queue, adapts to real load automatically. Weighted round robin assigns capacity weights. A 32-core server gets weight 4. An 8-core server gets weight 1. Like a relay race where the fastest runner carries the baton more often. Now, consistent hashing. Understand this cold for any senior system design conversation. With modulo hashing, add one server to 10, and almost every client remaps. Like renumbering every school locker when you add a new one. Every student loses their stuff. Consistent hashing uses a circular ring. Place servers on the ring by hashing their names. Server A at 12 o'clock, server B at 4, server C at 8. Each request hashes to a point on the ring and goes to the next server clockwise. Add server D at 2 o'clock. Only requests between 12 and 2 remap. Everything else, unchanged. This is why you can add capacity to Redis clusters or CDN edge nodes without invalidating everything. Cassandra uses this. DynamoDB uses this. Akamai patented it in 1998. Health checks. How does the load balancer know a server is dead before routing to it? Like hospital triage, before a patient sees a doctor, a nurse checks vitals. If vitals are bad, the patient doesn't go to regular consultation. The load balancer does exactly this: continuous vitals checking, automatic rerouting when something looks wrong. Every n seconds it probes each backend. Failed response or non-200 status. Server is marked unhealthy and traffic stops. Your health endpoint should not just return 200. Check database connectivity, cache, critical dependencies. A server that's up but can't reach its database is not healthy. Return 503 and the load balancer routes around it. Here's a failure mode that takes down balanced systems. The thundering herd. 10 servers, 1 goes down, 9 servers absorb its traffic. 11% more load. If they were already at 85%, 2 tip over. Now 7 handle 10 servers worth of load, 3 more fail, total collapse. Like rush hour, 1 lane closes, Congestion builds, more accidents happen, more lanes close. A fender bender becomes a 10-mile jam. The fix, rate limiting at the load balancer, circuit breakers, connection queue limits, return 429. Too many requests instead of piling onto struggling backends. Graceful degradation beats total failure every time. Two more concepts that appear constantly: SSL termination and sticky sessions. Decrypting HTTPS is expensive. If every backend handled SSL termination, you're burning CPU on cryptography instead of application logic. The solution: terminate SSL at the load balancer. Clients connect over HTTPS. Backends receive plain HTTP within the private network. This is why internal data center traffic is often unencrypted. The perimeter is secured. Sticky sessions route each user to the same server using a cookie or IP hash. The problem: if that server dies, sessions are lost, and it prevents true horizontal scaling. The modern solution: don't store session state on the server. Use Redis. Any server handles any user. Stateless design is not an opinion. It's a constraint for horizontal scaling. What routes traffic between data centers? Two mechanisms. DNS load balancing returns the IP of the nearest healthy data center based on your location. TTL is kept deliberately low. The weakness: DNS is cached everywhere. You can't instantly reroute all traffic. Anycast is more elegant. Imagine one customer support number that rings the nearest call center automatically. You announce the same IP from multiple data centers via BGP. The internet routes each client to the nearest one. Data center goes down. BGP withdraws its announcement. Traffic flows to the next nearest node. No TTL, no cache. This is how Cloudflare operates at the network layer. Production setup at real scale. Anycast at the edge routes to the nearest data center. Inside, a Layer 4 load balancer distributes raw TCP connections across a pool of Layer 7 load balancers. L4 is the highway interchange. Routes at speed without stopping anyone. L7 is border control. Inspects and makes intelligent decisions. L7 routes to application pools. Auth servers, API servers, video processing, health checks at every layer, circuit breakers between every tier. If the video pool gets overwhelmed, only video degrades. Auth still works. The API still works. Graceful degradation by design. Load balancing is a solved problem, but knowing which algorithm, which layer, how health checks work, what consistent hashing does, how global routing fits together, that's what separates someone who configures infrastructure from someone who designs systems. Next episode: caching. Cache invalidation strategies, eviction policies, and the cache stampede that takes down systems that look perfectly designed on paper. Subscribe to Byte Architect, one concept at a time. No hand-waving.